All right, welcome back, engineers. Today we're going to look at engineering disciplines. What is engineering? Well, we've kind of been beating that horse quite a bit lately, so let's get another definition of it. It's the application of mathematics and scientific principles to better or improve life. Again, still not far from just solving problems in life, solving problems in industry, at home, all sorts of things have to do with engineering. Big four. You're going to hear a lot about this as long as you're in this class. Let's look at the big four. We have chemical, civil, electrical, mechanical. Of course, chemical is listed first because it is the best engineering discipline, as you know. All of the other disciplines we're going to look at are a derivative, combination, or an extension of all of these. Chemical engineering. Well, what you do is you take the principles of chemistry, you mix up a little bit of physics and just general engineering to look at things that undergo a chemical change during their processing. And for example, some of them, they just kind of leave out the big one of making fuel. Oil refining is probably one of the biggest users of chemical engineers because from that oil and the byproducts, we make all sorts of other chemicals, like they're talking about here, fuels for rockets, fuels for other types of reactors, chemical reactors. We can make medicines from a lot of these petroleum byproducts. Plastics cannot be made without oil. So if we're talking about a world without oil, you're not going to have plastics in it. The next is civil, and as kind of related to it, construction engineering, where chemical engineering made things out of chemicals. Construction engineering makes things out of really solid material, so whatever you're building does not move. So you plan, design, and you can even supervise the construction of these really big things. It could be both for the public, as in building schools, building bridges for roads, or for private, which is just basically anything else that can be built. And all of these different areas that were shown here, space satellites all the way down to dams, you can make things really big or really small. They all have to do with civil engineering. Likewise, airports, stuff you got to land on, stuff you got to drive on, stuff you got to go under, over, or through, civil engineering. One big one, collection and wastewater treatment, before I move on. The building, the actual facility for that is civil, okay? Electrical and electronics, they're very similar in that electrical deals with power usually, and electronics are smaller things. So large electrical systems. So you got to make the electricity and then you got to send it all over the country. And then once you got it at a place, a house, a building, a factory, you've got to actually take it and use it. And how do they use it? By usually plugging in a motor or some kind of generator. You're looking at the electrical circuits that make sure the electricity goes where you want to and not go where you don't want it to go. Power transmission, that's a very big deal. You got to build the right kinds of cables and towers to make sure the electrical power goes all the way across the country. And where it is actually generated. It could be generated from nuclear power, from steam, from hydraulic. But once that electrical energy is generated, then it's basically the same. However it's generated, it's got to go to the right place. Mechanical engineering, that deals basically with things that move, things that rotate, things that propel other things. Things where you have a lot of metal or high technology plastics rotating back and forth. Mechanical engineering is used to design all that stuff. And when you have a lot of things rotating or moving, quite often you have heat generated. So that heat has to go somewhere. So the the cooling or lubrication systems are all mechanical engineering. Your heating and air conditioning also a lot of even though they're powered, can often be powered by electricity. The actual equipment is looked at by mechanical engineers. And as things are moving really fast, vibration is a very big deal because if something's off a little bit or you don't want it to rattle apart, vibration control, analysis and control is a big deal also. And as I said, lubrication of things that move, oil, water sometimes, other synthetic material, metal on metal gets really hot and will destroy something very quickly. Other things that make things go faster or slower as you want, those are gears, just like the gears in a car, bearings, ball bearings, things that improve the energy transfer as well as control heat transfer. Other things, we're going to go through these pretty quickly. These may be those areas where you find something really specific that you're interested in. Aeronautical engineering. Aeronautical means you're moving through the Earth's atmosphere. That's the main distinction. So when you want to fly, you want to make sure you stay in the air. You want to make sure you got something that is pushing you through the air. You need to make sure that something is controlling you so you don't run into something. Or while you're up in the air, you don't want to fall apart. So those four areas are the main areas where you're going to be working in aeronautical engineering. So as opposed to working in the atmosphere, let's go outside the atmosphere. That's aerospace or astronautical, like astronaut. Astronauts quite often deal with astronautical engineering, stuff that you don't find on Earth. You got to leave the atmosphere, and then things that leave the atmosphere, that's where this discipline of engineering deals with. So you got to get it up there. And as things are flying through the air, you got to go through the atmosphere to get there. And quite often, while you're flying through the atmosphere, you got to keep it cold because if you go fast enough, the air friction will heat and cook things. You may have heard about a lot of space shuttles that have, or other craft that have not had sufficient heat protection. They fall apart, and quite often they kill everybody inside. So, materials of construction are important. Navigation, you got to make sure you're going in the right direction. And once you're out in space, you don't want to get cooked by the sun or some other cosmic radiation that's out there. After space, well, let's bring it back down to Earth and stuff we eat. Agriculture, making sure that the land is maintained, cared for enough that we can increase production, but not completely destroy the farmland. So we're looking at land, water, soil, to grow things. And once you grow things, well, how do we improve what is grown? Then once something is grown, you gotta, till it. You have to plant it, harvest it, process it somehow. All this machinery has to be used to get the food from the farm to your table, or at least the grocery store. And there's all sorts of places you have to be concerned about where it's stored, etc. And nothing runs on your good looks or good intentions. So you got to have power, often electrical power, to run everything. Architectural engineering, it's an engineering discipline different than architecture in that there's a lot of structural analysis, structural integrity, and design work that goes into it. But because it deals with architecture, you have to be concerned with aesthetics, a fancy word for making sure it looks good. It's got to be pleasing to the eye, not just a big, ugly box building. And this is my favorite picture in the world. I want one of those things. But in general, automotive engineering, anything that travels for a purpose, automobiles, trucks, tractors, all sorts of things, you have to have some kind of motor inside, and that motor has to be the energy generated by a motor has to be transferred to something to make you go, and how all that works, whether it is doing wheels, whether it's doing treads like this, one wheel, two wheels, four wheels, however many wheels uh, need to be rotating. Automotive engineers make sure it's done efficiently. Whether you want more power, more speed, more torque, all sorts of things go into this, even down to how to make or how to design the tires. And interestingly enough, tires quite often are made by chemical engineers. Those of us who are looking more and more like we may need artificial parts to replace some of our joints, we hope biomedical engineering does its job. That we have good people designing parts, replacement parts due to health related or injuries. And engineering goes into designing them and make sure they operate. So you have to bioengineer it. You've got to make sure it can go into a human body, and then you have to make sure that it stays in there, excuse me, and fits and continues to work. A lot of you may be interested in computer engineering, computer science. Computers get more and more powerful, and you need people to take advantage of that. If there's something that you want a computer to do, computer engineers are the ones to do it. And you have to look at two different things. The hardware, that's the stuff you touch, that's the stuff you see, that's the stuff that makes the noise. The software, that's the programming, and that does the computer actually create whatever you see on the screen. So who do you think is the largest consumer of computers today? The automotive industry. You look at a car, nothing runs in a car unless it's controlled by a computer. If you have a computer problem, there's nothing. You can't lift your hood and take out your toolbox and try to fix it. It's probably a computer problem. Industrial engineering. It's called something different, but basically, an industrial engineer makes sure that whatever goes on in a manufacturing system is as efficient as possible. You make sure the material gets in when you need it. Make sure the product goes out. Make sure you have the right number of people. Make sure you have the right machines, that they're all located, and so you can get it done as quickly and as cost effectively as possible. Also, safety. Safety is a big deal. So, whatever it takes to make your product, the raw materials in, the people, and the product out, and everything that goes along with that. Slightly different than that is manufacturing engineering. And that's where you actually design the piece of equipment themselves, whether it's a robot or something mechanical. Yes, you can design a robot, you can program a robot, but you actually have to put it together so it goes out and fix. And as you can see, all of our jobs are going to be replaced by robots. Burger King, it can be instead of hiring high school kids, they're going to start hiring robots. So all of these things are examples of manufacturing engineering. So that concludes the engineering discipline. If you have any questions, let me know and I will be able to answer them. Otherwise, thank you for your time.